Hi friends, let's get into the third module. It's all about feature generation and feature selection. The feature extraction, it's a process of extracting the meaning from the data. It is essential for deriving the insights from the data. It is helpful in making informed decisions and helpful in solving problems in various fields. So before getting in detail, let us see some data science competitions. So, knowledge discovery and data mining competitions are available online. So, many such competitions are there. So, we can get into these competitions and know more about the data science, data mining, and all other features of data science. So, one of the favorite popular competition is Kaggle. Then we have crowdsourcing. So the concept of using many people to solve problem independently. So the knowledge discovery and data mining competition is a concept of using many people to solve a problem independently. And the basic idea is that a challenge is issued and contestants compete to find the best solution. So in this competition, we give our own solutions for a given problem, and later we can look at others' solutions and make out how others have solved and compare with our results. And through this, we can learn more. So it will be one of a better way of learning through sharing the concepts, through sharing the problem solving ideas. So there's another similar competition by Amazon. Amazon Mechanical Turk is an online crowdsourcing service where humans are given tasks, and these tasks might be a set of images that need to be labeled as happy or sad. So as we have seen in our previous session that there is a one type of machine learning called supervised learning. In the supervised learning, for every input data, there is a label. If we are talking about classification problem, then there will be some situations where we need to classify the images. So one of the uh, tasks Amazon Mechanical Turk has found is to classify whether a given image or a person in the image is happy or sad. So for training, we need label data. So we need many such labeled data, but getting data is easy, but labeling them is a big task. So we can make people engage through such competitions like a online crowdsourcing service, and humans who are interested in such tasks can participate, and the more number of activities they perform, the better they perform, the higher ranking they will get. So in a competitive spirit, many people will be working towards this goal, and the one which does the best may be given some awards, rewards, and all that. So because of these awards and rewards, people will be attracted and they keep doing these works. Now let's look at what the Kaggle model is. It's a popular platform for data science competitions. So data scientists and machine learning practitioners compete to produce the best predictive models for any given specific tasks or the data sets. Kaggle fills the hole between those who need analysis and those with skills. So there are some people who have data, they need analysis. There are some people who have skills. So the people who have data and they want analysis, they lack the skills. And the other side, those who have skills, they may not be having opportunity to work with any data. So it gives the link between the one who needs analysis and the one who has skills. So there is a wonderful platform, Kaggle, which links these two worlds. So the Kaggle process, a competition will be announced. It may be a user or it may be a company or any government organizations. So depending on the situation, a competition will be announced. Then data will be provided to access. So the competitors will access the data and they build the model. They train and evaluate the model. And finally, if they feel satisfied with the performance of the model, they submit. And all the people who have submitted for this particular competition are listed on the leaderboard depending on the performance of each one. So the model whose model performs best will be a number one in the leaderboard and so on. So this way, when we get into any competition, so we access the data, look at the problem and try to solve them through building the model and then train the model and evaluate the model. And if we assume that our model is doing well, we submit it and then look where we stand in the leaderboard. If we are not happy with that, then we can redesign our model. We can retrain the model, re-evaluate, resubmit. So this process can be repeated any number of times till the last date is. So once the last date is done, then final evaluation. So those who have topped, so the first, second and third will get some cash prize and so on. So this the purpose of doing this, number one, if a big company has got a small problem to get it solved, instead of creating a new team to solve that small problem, they can publish it on Kaggle, and so many people all around the world will participate to give the best possible solution, and the company will use this best possible solution by paying some nominal rewards. So the reward, whatever they are paying for this first three winners, is a meager amount compared to the money they need to spend to create a team and maintain and come out with the solution. So whenever we have a smaller problems, we look for such a process. Then comes is feature extraction. Most of the time the data what we have will not be in a proper shape that is directly helpful to solve our problem. So in such cases we need to extract features from the given data. And this process, feature extraction, is a process used in machine learning and signal processing to select, enhance or transform certain features or characteristics from the raw data that are most relevant to the task at hand. So most of the time the data may not be directly useful, so we need to either unnecessary data are there, so we need to select only necessary data, and some data may not be in proper shape, so we need to enhance their quality, or we may need to transform into some other domain so that the overall performance improves, so that can help us in solving problem more easily than using the raw data directly. So that's the basic concept of feature extraction. So this process can involve mathematical techniques, algorithms, or domain specific knowledge to identify patterns, structures, or properties in the data. So when we are working with the data, we are actually working with big data that has got multiples of parameters and many data points. So that means hundreds of parameters and millions of data are available. So from these hundreds of parameters, selecting the appropriate parameters that will solve our problem is one of the big tasks we need to perform during the pre-processing, and once that is done, our next process becomes simple. So for doing that, mathematical techniques will be used, some algorithms can be used, and definitely we need domain specific knowledge for identifying these pattern structures or properties in the data. Feature extraction also is useful in reducing the dimensions, so the number of parameters in the data, all of them need not be useful for our problem solving. So what is required, only that part has to be identified, and one option would be just select them, whatever is required, and remove whatever is unconcerned with our result. So here we can look at the correlation logic we discussed in earlier case. So the parameters which has got some correlation with the result will be retained, and the parameter which does not have any correlation with the results will be removed. So that way we can reduce the dimensionality, or a combination of these can be used together mathematically and reduce to a lesser number of new parameters. So we can generate new parameters from the existing parameters, but the new parameters are less in number compared to the existing number of parameters. So that way we can reduce the dimensionality, and the dimensionality is reduced. That means the number of parameters, if you reduce, the size of the data will reduce. If the size of the data is reduced, then the training process will be simplified, and hence it becomes faster. And if the data is reduced, the size space requirement is reduced. So in all, the time complexity and space complexity will be reduced, and hence the training process will be much more better than the previous one. The feature extraction also represents it's a form of a representation learning. So here it's we are learning through representing. Then we can use domain specific techniques for extracting the features. For example, if we are talking about natural language processing, then the data is a sequence of words. So that's a data we have, but what we can generate out of that is word frequency, syntactic patterns, word embeddings, and so on. So these are nowhere visible in the real data. The real data, if you look at for natural language processing, is sequence of characters or sequence of words, and these words are used, are pre-processed to find these domain specific features. So we extract the features. So if it is a computer vision problem, then what we have is the data about every pixel, red, blue, green values, RGB values of each pixel, but doesn't have any other information. From this RGB values of each pixel, we should be able to extract features like edges, textures, and color histograms, and so on. So that's what feature extraction means. So here we are interested in extracting some meaningful information out of the raw data, and that's for now. So let's continue more details in the coming session. So keep watching. Thank you.